How to perform operations with irrational numbers. Have you ever wondered how to handle those tricky numbers that just don't fit into neat little boxes? Today, we are going to tackle the fascinating world of irrational numbers and how to perform operations with them. Irrational numbers are those that cannot be expressed as a simple fraction. Their decimal forms go on forever without repeating. Think of numbers like the square root of 2, pi, and the mathematical constant e. When it comes to addition and subtraction, things can get interesting. If you add or subtract two irrational numbers, the result can be either rational or irrational. For example, if you have to square roots of 2, you can combine them easily. So square root of 2 plus 3 times square root of 2 equals 4 times square root of 2, which is still irrational. But what if the irrational parts are different? In that case, you might end up with an irrational number, but sometimes they can cancel out. For instance, if you take 6 plus square root of 2 and add it to 2 minus square root of 2, you get 8, which is rational. Now let's talk about multiplication. When you multiply two irrational numbers, you can also get either a rational or an irrational number. For example, if you multiply 2 times square root of 3 by 6 times square root of 3, you get 36, which is rational. However, if you multiply an irrational number by a rational number, like 6 plus square root of 2 times 2, you will get 12 plus 2 times square root of 2, which remains irrational. Division follows similar rules. Dividing one irrational number by another can yield either a rational or irrational result. If you divide an irrational number by a rational number, you typically end up with an irrational number. Here are some practical tips for working with irrational numbers. When you are doing calculations by hand, try to express them in simplified radical form. This can help you identify common parts for addition or subtraction. Using properties of square roots can also make simplifying results easier. While calculators can give you decimal approximations, it is often best to keep the exact forms in algebra to maintain accuracy. Understanding how to perform operations with irrational numbers is essential for building a solid foundation in algebra. It helps you recognize when results remain as irrational or simplify to rational numbers. This knowledge is key for solving equations and working with real numbers in various math contexts. So, embrace the challenge of irrational numbers, and you will find that they can be handled with confidence.